once again, everybody, this afternoon. I want us to look through mathematics in particular measurements, capacity, and volume. Today, I want us to pick up from the past class 4-5 when we were introduced to us the use of solids. But this time, I want us to emphasize on the formula volume is base area times height. And I want to bring to the attention of all of us using and utilizing a rectangular object like a cube. When I have a cuboid, everything is built from the rectangular base, and I have 24 centimeters and 15 centimeters. This becomes my base area, and therefore all along what I need to do is to remember to calculate the area of the rectangle. The base for this case is rectangular. So wherever I go up in terms of height is what I want us to be very clear about. Number one, if this height is 15, then we will say volume is the base 24 times 15. Calculate that multiplied by 15, and this should be able to give us the volume. Now, what happens when we bring in water to a certain level and we put in water to the green mark, which is 8 centimeters? You will appreciate that here the base does not change. The base will still remain. For that particular case, it is 24 times 15. That is still our base. What is it that is changing? It is the height. Because here we had 15, now the height becomes 8. So we'll multiply by 8. And this should be able to give us something like 2,880 cubic centimeters. That is the amount of water intake that is supposed to be inside there. But supposing the same question is brought to us and we are told, calculate the space that has no water. This is again where we're saying volume is base area multiplied by height. What is the base area here? The base does not change. It is 24 times 15. But the height will change because initially the whole thing is 15 and we have water up to 8. So we'll take 15, take away 8, and this will be 360 multiplied by 7. And this one becomes 2,520 cubic centimeters. Right? This is the emphasis of base area, and we can see the base area all along into good use. I will also want to move to the next level and see us using the base area, but this time we'll use it as cross section. We'll use it as cross section. That volume is cross section multiplied by length. This time the same height becomes, we will use the word length. And I will use a good example here. I have a rectangle in this manner. I have a rectangle of that manner. We are told this is 15 centimeters. This is 8 centimeters. This is 12 centimeters. And this one here is 10 centimeters. I would therefore say this will be 5. What about here? The total line height there should be 8 plus 12. That gives us 20. So if we wanted to get the area of this figure, we'll end up creating we'll be creating 2 rectangles. And we can easily use this one here. We have left 12 times 15. That gives us 60. Down here, it will be 15 times 8. That will be 120. So our total area is 180 square centimeters. Everything is based here. And I'm going now to use the same diagram and create a volume. And I'll pick here as it is. Remember, this is 15, that is 8, that is 10, 12, 5, and 20. I will use a different marker pen, blue, and I pull a length here, which is 15. It will give us a 15 there, a 15 there. Everywhere we have pulled by 15. All this extension, our cross section is the red part, the red diagram. Everything has been built on the red diagram. So our volume therefore will be volume, the area of cross section multiplied by length. Our length is 15. So in this case, our area, which was 180, is 180 multiplied by 15. And for heaven's sake, quick mathematics says this is 2,700 cubic centimeters. So boys and girls, thank you very much. So today, what we've been going through is measurement, and that is volume of solids. And we have tackled the use of base area multiplied by height as a formula to calculate the volume of a cuboid, and the volume of a solid given a cross section. It is volume is equals to cross section area multiplied by length. Thank you very much, and I want to wish you some good time.